Hey there, everybody. So this is the algebra challenge number 4. And as you can see, our target is all about distributive property in this one. So really just two main goals here: to learn the meaning of the distributive property and then apply the distributive property when solving for variables. All right, I think the best thing to do is start with an example. All right, so in this case, what we want to do is multiply 3 times x plus 5. So note I said multiply. I just want to remind you, in algebra, when anything is written right next to a set of parentheses, that means multiply. We just assume that's multiplication, right? If it were anything else, we'd have to put a symbol in there. So if it were addition, there'd be a plus sign here. If it were subtraction, there'd be a negative sign here. By the way, we'll talk about that at some point, subtracting. If it were division, there'd be a division sign here. All right, so since there's no sign, we assume it's multiplication. All right, remember, multiplication is really finding groups of. So the proper way to say this when thinking about it conceptually is how much would be in 3 groups of x plus 5. All right, so here's one group of x plus 5. Here's a picture that shows you 3 groups of x plus 5. And you can see when you look at that, you've got 3 x's and you've got 15 units. So we would say that as 3x plus 15. All right, so here's the answer here. When we're working with distributive property, though, when we're just doing it on paper pencil, what we say is we distribute the 3 to each of the terms inside the parentheses. So 3 times x is 3x. So there we have it, 3 groups of x. And 3 times 5 is 15. Oh, 3 groups of 5, 15. The thing is, you have to multiply each term inside the parentheses with what's outside the parentheses to get the correct answer. One common mistake I've noticed students make when they first start learning about distributive property is they'll only distribute the 3 to the first term. So they would say that this is 3x plus 5. But you can see that's not the case, because if you're taking 3 groups of this whole thing, 3x plus 5 would actually knock off 10 units, so that wouldn't be correct. You do have to multiply each thing inside the parentheses. All right, let's look at an arithmetic example of this, so you can see that this works no matter what. If I had this in arithmetic, 4 times 2 plus 3, I would do this. I would take care of what's in the parentheses first. So 2 plus 3 is 5, and then I'd do 4 times 5, which is 20. Right, so right here, right, 4 groups of 5. Right, but you can also multiply each thing separately. You could also do 4 times 2 first, and then 4 times 3, and then add it together. That would give you 20. All right, well, this shows kind of a picture of that, but you can see all that happened is we just split these units up. It's still the same number of units in each of them, right? But here is my 4 groups of 2. Here's my 4 groups of 3. So here's my 8, here's my 12. But no matter what, you do end up with the same answer. Okay, so in this case, we did some work where we solve for variables using the distributive property. All right, so let's talk about this just a little bit. So you can see what I did here was, first thing I did was distribute the 7 to both the x and the 4. So that ends up being 7x plus 28 equals 42.7. Right, and then from here, I'm just going to solve for variables like I've showed you in previous videos. So first thing I'm going to do to isolate the x is subtract 28 from both sides, or combine it with negative 28. That leaves me with 7x equals 14.7. And then the last step is to divide by 7. So when I divided both sides by 7, I ended up with x equals 2.1. Right, I'm just real quickly mentally going to double check this. So if I put a 2.1 in here, this becomes 6.1. And 7 times 6.1 is indeed 42.7. All right, so please double check things, and certainly feel free to use a calculator. I try to do math in my head, just keeps me sharp. All right, so if you can do math in your head, that's great. All right, let's try one on our own here. All right, so there are a few interesting things about this one. All right, first thing I want you to notice is we have a negative here. When you're distributing a negative, You do distribute this as -5 times b and -5 times 4. I'll show you in another slide why that works, but let's just distribute it as -5 for now. So I end up with -5b minus 20 equals, all right, now in this case, I'm only going to distribute the 7 to what's in the parentheses, right? So this 3 I'm going to leave alone, right? So it's just going to end up being 7b plus 21 plus 3. All right, so note, I only distributed to what's inside the parentheses. Another common mistake is just to distribute to everything over here, only what's in the parentheses. Another mistake people make sometimes is they'll distribute like the -5 here, and then they keep going with -5. It's like, nope, you only simplify one side of an equation at a time. You should do that separately, right? So you simplify one side, then simplify the other separately, or you're going to end up with some errors because you're going to change the value of what's here. Okay, so be careful about that. All right, but now you can see, since I've done the distributive property, now I need to combine like terms. All right, so if you have to do both, make sure you're doing the distributive property first, okay? Really think about that like order of operations. Distributive property is like multiplication. Combining like terms is like adding and subtracting. So you want to do your multiplication first. All right, so on this side, when we're combining like terms, we end up with 7b plus 24. Okay, now I'm going to work on solving when I have variables on both sides of the equation. So what I'm going to do is I'm going to subtract 7b from both sides to get the 7b off the right. So I'm doing some of this in my head. So then I end up with -12b minus 20 equals 24. All right, now what I'll do is add 20 to both sides. So I have -12b equals 44. Okay, I know right now that's not going to go in evenly because 12 times 3 is 36. 12 times 4 is 48. So let's give this a shot. I'm going to divide both sides by -12. All right, so that makes my answer over here automatically negative. So b equals. All right, so I'm going to go with 3, which is 36. All right, I think I'm going to write this one as a fraction. So let's see, 44 minus 36, that would be 8. So 8/12, that would be, I can divide both by 4, that would be 2/3. All right, so then my final answer here is b is equal to -3 and 2/3. I think it is best to leave that one as a fraction. Sometimes I like to go to decimals, but in this case, 2/3 would be just a repeating fraction, 0.6 repeating. That's not really what we call exact, right? The best you can do is approximate there. So I think 2/3 is the better answer. Okay, let's take a look at this one. All right, this one just has two positives that we distribute. All right, and there's no combining like terms with this. So first I'll distribute the 4. So this becomes 8m minus 12 equals 6m minus 6. All right, and then what I'm going to do is subtract the 6m from both sides. So I have 2m minus 12 equals -6. And then last step here, I'll add 12 to both sides. So 2m equals +6. Divide both sides by 3, so m equals 3. All right, I'm just going to double check this one real quickly. It's easier to check mentally than a fraction was. So if I had this, this would be 6. 6 minus 3 is 3, so 4 times 3, that's 12. All right, got to remember this is 12. And then if I put the 3 here, 2 times 3 is 6. 6 minus 2 is 12. 3 times 4, also 12. Okay. So I end up with 4 times 3 equals 3 times 4. Yes, of course. What a good picture of commutative property, right? So there's one for you to look up. Look up commutative property. I just want to show you right here why you end up switching the signs of everything when you're distributing a negative. So you can see we've already done a little bit of this. So this is -3x minus 12. I just want to say when you're taking the negative of an expression, that means you're finding the opposite of everything in there. All right, so if this is x plus 4, this is the negative of x plus 4. You basically find the opposite of every single thing. So you'd have to flip all of them. Another word that can be used in place of negative is opposites. So the opposite of x is negative x. The opposite of 1 is negative 1. All right, so anyway, here's one negative group. So then this would be 3 of those negative groups. So you can see that is negative 3x minus 12. That's really just why you just make sure that when you're distributing with a negative in front of this, you are making sure that you're changing the signs of everything on the inside of the parentheses. All right, let's try one more together and then I'll have you do some practice. So in this case then, we're going to be distributing a negative 5 here. All right, now if I said this out loud, I would say 3m minus 5 times 2m plus 3. That's okay, it is subtraction. But when you're thinking in algebra, thinking algebraically means thinking about this as a negative. So what we're going to do is distribute the negative 5 to each thing inside the parentheses, and that takes care of the negative. Okay, so the 3m stays the same. Note, I don't need to write that subtraction sign. I'm thinking about it as a negative. I'm going to take care of that as I'm distributing. Okay, so negative 5 times 2n is negative 10m, and then negative 5 times positive 3 is negative 15. Note, by the way, I'm just simplifying this. I'm not trying to solve for any variables. It's not an equation, it's just an expression. So I'm simplifying the expression. So then this ends up being negative 7m minus 15. Okay, it's more like it's just one side of the equation. Oh, that should be 15, not 16. There we go, that's better. All right, so negative 7m minus 15. All right, so here's what I'm going to ask you to do. I'm going to ask you to try some problem sets on this website, and I'm going to leave you the link in Google Classroom. There are a couple of annoying things when you're working with these problems, and I just wanted to share them with you because I got a little frustrated with this. So you'll see down at the bottom of the page, there's this little guy, and it says, okay, Charlie, how'd I do? So when you check on that, Charlie will tell you how you did. But Charlie marks some things wrong unless you're following proper terms or proper mathematical form, right? So these are the two things that if you pay attention to, you'll be a little less frustrated. So make sure you put any terms with variables first. That is proper mathematical form. Okay, so the correct way to write this would be negative 7b minus 12. The incorrect way to write this would be negative 12 minus 7b. These are technically the same answer. All right, so technically they're both correct, but this is proper form, and this website will mark it wrong if you don't put it in proper form. All right, the other piece that's proper form is terms with variables should be in alphabetical order. So the correct way to say this trinomial, how'd you like that? Or check that out, what's a trinomial? But the correct way to say this trinomial is 3x plus 5y minus 7. This would be the incorrect way to say the trinomial, 5y plus 3x minus 7. That's because they want you to put the variables in alphabetical order. Again, these are the same. They're really, in terms of the mathematics, they are the same expression. This is just proper form. Okay, so give that a shot. What I'm going to have you do is report to me how many sets you did. I want you to do at least one set. And then report to me how many you got right. And if you do more than one set, that is fantastic. All right, nice work on algebra, everyone.